Hello students, welcome you all in today's class. Today we are going to discuss an important topic of atomic structure. In atomic structure, you have to learn the word spectrum, the meaning of the spectrum, its application of the spectrum, and also the importance of the spectrum topic in your competitive examination, school examination. Okay, so without wasting our time, we are going to start with the topic spectrum. I think all of you know the word or familiar with the word spectrum from the previous classes when we are learning about the Bohr's atomic model. During the learning or during the classes of the Bohr's atomic model, we learned that the Bohr's atomic model is not able to explain the spectrum of hydrogen atom. Okay, you heard the word spectrum. Also, when we are learning about the limitations of the Bohr's atomic model, I explained that Bohr's atomic model could not explain the splitting of a spectral line in the presence of electric field as well as the magnetic field. It means Zeeman effect and Stark effect. Okay, so if someone asked what you mean by the word spectrum, simple, in one word or two word you can say the band of colors. When so many colors are either merged to each other or there is some dark lines between them, this is called the spectrum. A spectrum can be natural as well as artificial, man-made. All the atoms have a different spectra. Like the natural spectrum, you all familiar with the natural example rainbow. Vibgyor, 7 colors are there. So what you can see, what is a spectrum? Recall, the band of colors are called spectrum. You can read this definition also, the band of colors corresponding to certain wavelength. Why? Because color represent the wavelength. Every color have a certain range of the wavelength. That's why I wrote here the band of colors corresponding to certain wavelength which appear when light radiation passes through the prism on any water solution. Not the essential condition that it must pass through the prism, but we generalize that it passes through the prism. And my dear student, when we are learning about the Planck's quantum theory, you know that according to the Planck's quantum theory, the light radiations are emitted or absorbed discontinuously, not continuously. So if the light radiations are emitted or absorbed discontinuously, so my dear student, very important point, the atomic spectrum is a discontinuous spectrum. But our natural example, the rainbow, where one color merge with other color, is an example of continuous spectrum. It means rainbow is an example of continuous spectrum, but atomic spectrum is an example of discontinuous spectrum. Dear student, what we are learning now? Your answer, sir, we are learning about the spectrum. Yes? So, when we learn about the spectrum, its types and how it work, how it produce and its effects, then the study of different type of a spectrum is called spectroscopy. Is a class, or you can say the branch of science where we discuss in detail about the spectrum is called spectroscopy. I think up to here it is clear to all of you. Keep listening carefully without any disturbance, because the next things that I'm going to explain is very important for you. All the atoms have a spectrum. The complexity of the spectrum depends upon the number of electron or its atomic number. Then my dear student, you are thinking, sir, hydrogen have only one electron. So you are predicting right. The simplest spectrum of hydrogen of an element is hydrogen. Or you can say the hydrogen will have the simplest spectrum because it contains only one electron. The rest of the element containing 2, 3 and 4 electrons will have little more complex spectrum. But in class 11th, my dear student, we have to learn only about the spectrum of the hydrogen. So remember one word again, the spectrum or atomic spectrum is always a discontinuous spectrum. Complexity of a spectrum depend upon the number of electron. If an element have only one electron, that is hydrogen, its spectrum will be simple or simplest. So the spectrum of hydrogen will be simplest as it contain only one electron. Clear to you? Now two important point I am going to explain you, because direct question from in the examination from these 2 points. Remember, and you have to write in your notebook. Okay, no two no two different element or ions, no two different element or ions, even isoelectronic means those species having the same number of electron. No two different element or ions, even isoelectronic, can have identical spectrum. It means all the atoms or ions have a different spectrum, just like all of you have a different fingerprints. So my dear student, as the fingerprint of each and every human being that are living on the earth's surface have a different fingerprint, similarly each and every atom those are discovered, or the element those are discovered till now, or will be discovered in future, definitely have a different spectrum. The spectrum of two different elements can never be identical. So we can identify a particular element with the help of the spectrum of that atom, because all the elements are almost silvery white in color except a few. So we can identify the element on the basis of the spectrum of that element. So my dear student, we can say spectrum is the fingerprint of an atom. Up to here it is clear to all of you. Hope you are enjoying this video. If you like this video, please don't forget to like, share and subscribe my channel. Okay, coming to the next point. This is very important, and now we are going to discuss in detail about the hydrogen spectrum. Why hydrogen spectrum? Because it is in our syllabus, and also it is the simplest spectrum because it contains only one electron. If an element containing one electron, we can call it as monoelectronic hydrogen atom. Okay, see, monoelectronic hydrogen atom have only one electron, but it produces number of spectral lines, because electron present at higher energy level have a different ways to achieve the lower energy level by releasing corresponding energies belong to the certain wavelength. Okay, I think many of you are not able to understand what it is written. What I want to explain is a monoelectronic species. The question is that if hydrogen have only one electron, so it must have only one spectral line. But it is practically observed through the experiment that the hydrogen have so many spectral lines. Okay, the question is why hydrogen having only one electron is producing 4 or 5, even sometimes 6 spectral line. The answer is that the electron that is present at higher energy level, orbit number 1, orbit number 2, orbit number 3, the electron that is present in higher orbit or higher energy level have a different possibilities, different ways to achieve the lower energy level. By releasing corresponding energies belonging to the certain wavelength. My dear student, I want to give one analogy so that you can relate. Suppose you are standing on the 10th floor of a building. You may have a different ways to come to the lower first floor. Okay, directly you can come to the third floor. Maybe directly you can come to the first floor through the lift, or different ways. Or even if you are the Spider-Man, you can also jump directly to the ground floor. So there are various ways, or the different ways from come from higher energy level to the lower energy level. That is the reason hydrogen having a single electron or one electron, even it is producing so many spectral line. This question is important for assertion and reason. They may ask why hydrogen even having one electron is producing so many spectral line. The answer will be that the electron present at higher energy level, my dear student, remember this, the electron present at higher energy level have a different ways to achieve the lower energy level. This different ways results in the production of the different spectral line in the hydrogen atom. Let's discuss about the different series or the spectral line of the hydrogen atom. I think you all are familiar with this Lyman series, Balmer series, Bastian series, Barakat and Pfund. in NCERT or up to school level, you have to learn up to P-Fund series, that is 5 series only. If the latest series that is discovered is known as the Humphrey series. Okay, so my dear student, this series depend upon the name of the scientist. First series that is discovered is Balmer series. Why? Because it lie in the visible region and human can easily identify the visible region. Because out of so many series, first series that is discovered is Balmer series. And also they may ask the question which series lie in the visible region. So your answer will be Balmer series. After that, we have Lyman series that lies in the UV region or ultravioleted region, and Paschen series IR region, it means infrared region. Barakat series IR region, infrared region. P-Fund series IR region, infrared region, but Humphrey series lies in FIR region. No, it is far infrared region, not FIR like police FIR you are thinking. Okay, far infrared region. Okay, now I want to explain this chart. Final, the electrons that are coming to the final stage, to the first orbit, then it will be Lyman series. The if electron are coming from higher energy level to the second energy level, then it will be Balmer series. As you can see, electron are coming to the first energy level. At first energy level, electron can come from the second energy level, third energy level, and fourth energy level, and so on. It means electrons are present initially at higher energy level. So Ni or Ni represent initial energy level, while NF represent the final energy level. If I ask about the Paschen series, electron will come to the third energy level from fourth, fifth, sixth, and so on. Similarly, Barakat series, electron come to the fourth energy level. It means final stage for the electron in Barakat series is the fourth energy level or the fourth orbit, but it is coming from the sixth, fifth, sixth, seventh, and so on. Okay, so for particular series, NF is fixed. Are you agree? Yes, because final they are coming to that energy level, but they may come from higher and higher energy level. So NF is always fixed for a particular series. I want to show one example so that you can understand. I have to take the help of one book so that you can understand this. See, my dear student, here this is Lyman series. Okay, the electron are coming to the first energy level. It means final stage is n is equal to 1. But this electron can come from the second energy level, also can come from the third energy level, fourth energy level, fifth energy level, and so on. So for Lyman series, the final stage is n is equal to 1. So NF is 1 for Lyman series. Similarly, my dear student, visible region or the Balmer series. Finally, in Balmer series, all the spectral radiations are coming to the n is equal to 2 energy level. But they may come from third energy level, fourth energy level, fifth energy level, sixth energy level, and so on. So I think this diagram will help you to understand about the spectral lines in a better way. Okay, in this diagram you can also see the Lyman series, Balmer series, Paschen, Barakat, P-Fund, and the Humphrey series. Hope it is clear to all of you. Thank you so much, and we are moving to the next mathematical approach of the spectrum. See, my dear student, as you can see on the screen, this is the starting of the formulas how to calculate the wavelength associated with a particular spectral line. In the previous classes or in the beginning of this chapter, I discussed that the ratio or the reciprocal of wavelength is called the wave number and is denoted by the nu bar. Okay, where RH is a constant, I will tell you what it constant. It is a Rydberg formula. It is the Rydberg formula to calculate the wavelength of the spectral line. So this constant is known as the Rydberg constant. Is known as Rydberg constant. 1 upon lambda is equal to RH Rydberg constant bracket 1 upon NF. It means final stage of the spectral line. NF square minus 1 upon NI square. This formula will be used when you are using hydrogen atom or you are solving the question that is related to the hydrogen atom. But when you are solving the question related to the monoelectronic species like He plus, Li2 plus, Be3 plus, then these are not exactly hydrogen, they are monoelectronic hydrogen like species. So my dear student, you have to multiply that value with the atomic number or the square of the atomic number. See the similarities between the both formulas. Only one additional constant we multiplied is the atomic number square. Okay, so in order to calculate the wave number or the reciprocal of wavelength, we can use these two formulas by putting the corresponding values of NF final and Ni initial energy level. Okay, hope it is clear to all of you. Now to calculate the frequency, you know that frequency is equal to C by lambda, and 1 upon lambda, the formula is this. For 1 upon lambda, that is wave number, and so we multiply it RH Z square, and I multiply the value by C, so it will result in the frequency calculation. Okay, now you all know where NF or N1, in NCERT they use N1 and N2. Okay, so NF or N1 is the lower orbit or where the electron reach by losing energy. It means final stage of the electron. Ni initial or N2, it means starting phase from where the electrons are coming. Higher orbit number from where the electrons is coming. This Rydberg constant have a certain fixed values. RH, Rydberg's constant, 109677 centimeter inverse, or 109, by approximation, by rounding off I can write it as 109700 centimeter inverse, 10970000 meter inverse, and 1.09 10 to the power 7. I'm just converting it, they are not the different values, all are the same. Okay, 10 to the power 7 meter inverse, or 1.09, I can also write as 1.1 into 10 to the power 7. But some of the student, if you want to solve the numerical very fast or to get the approximate answer, especially in case of MCQ, then you can put the value 10 to the power 7. Okay, meter inverse. And also if you want to have to solve the numericals like this, 1 upon RH, sometimes you can put 912 angstrom value depending upon the numerical. When we solve the numerical, then you will be able to find out which value we have to use. Okay, clear to you? Now we are going to start some important formulas about the solving of spectral line questions. Okay, listen carefully my dear student. Yes. Okay, the topic that I'm going to discuss now is especially for JEE examination and JEE advanced examination. Okay, here students are confused. They will ask you to calculate the maximum wavelength, minimum velocity, and maximum velocity with which the electron can come from higher energy level to the lower energy level. So I'm not going in detail to learn all the formulas and how this formula is coming. I'm going to tell you the best trick from which you can directly write the answer and tick your option within fraction of seconds. Okay, a spectral line having the maximum wavelength. If in the question it is asked to calculate to find out the spectral line having the maximum wavelength or the lambda max, if the wavelength is maximum, then the velocity or the frequency will be minimum. Okay, so n1 is equal to n, because lambda max, if we have to calculate, n1 is equal to n, and n2 is n plus 1. By putting this value, lambda max we can calculate as n square n plus 1 whole square 2n plus 1 rz square. From this we can also relate that the wavelength is inversely proportional to the change in energy. This formula is very important, I think. Yes, some of the student I think confused. A spectral line having the maximum wavelength. If we have to calculate the spectral line of maximum wavelength, it means we have to consider the first line. Okay, so let's assume for a particular series the first line is n. For Lyman series it will be n, for Balmer series it will be 2, for Paston series it will be 3, like this. Okay, and n2 will be n plus 1 because the electron will definitely coming from higher than this or energy level. Okay, then if I put this formula, and I'm not going to show you the detail from where this formula came, this is the final formula through which you can directly write the answer. Lambda max maximum wavelength is equal to n square n plus 1 whole square 2n plus 1 rz square, where r is the Rydberg constant and z is the atomic number. If for the longest wavelength energy is minimum, then n minimum and first line. I already told you, if you have to calculate the maximum wavelength, then you have to consider the first line. Now after, my dear student, we are going to move about the spectral line having a minimum wavelength. Just opposite. If it is a minimum wavelength, lambda minimum or Vmax, n1 will be an any energy level, Lyman, Balmer, Paston, and you have to calculate the minimum wavelength. So you have to consider the electron that is coming from infinite distance to that energy level. So n1 the energy level, and electron should come from the infinite. Then only you can calculate the minimum wavelength or maximum frequency. So while putting all these values, when we put all these values, you will get n square rz square. N square rz square. It means if you want to relate, both the formula are relatable. If you want to calculate the maximum wavelength, the whole formula, and if you want to calculate the minimum wavelength, replace this term in the bracket. If you replace this term in the bracket, remove this term, then you will get the formula to calculate the wavelength, minimum wavelength. Okay, same as above, for shortest wavelength, delta E or the change energy is maximum and maximum. So last line, that is infinite line, as I already told you. Now ratio of maximum minimum wavelength. For atomic structure, a numerical approach in the previous videos, I already told you radius ratio, frequency ratio, velocity ratio. This ratio concept is very important for the examiner. If you are using the general formula, same formula, then it will take more time. So ratio, for the ratio calculation, lambda max upon lambda minimum, you can n plus 1 whole square 2n plus 1 square, because this will be cancelled. If you know mathematics, you can relate. Key point for the numericals, my dear student, especially for the competitive examination, like alpha line means first line of any series. For example, Balmer series, we have the first line is coming from n is equal to 3. So alpha line, if they ask to calculate the wavelength of alpha line, that you have to put n is equal to 3. Beta line is the second line and gamma line is the third line, and similarly like this. Nth excited state will always be n plus 1. In the previous videos I already told you, if I'm saying the second excited state, it means it is the third orbit. So n plus 1. In order to calculate the number of spectral line, we have to use these formulas. Total number of spectral line is given by n2 minus n1, n2 minus n1 plus 1 upon 2, where n2 is always greater than n1. Okay, n2 is the initial stage from where the electron is coming, n1 is the final stage. Okay, total number of spectral lines to the ground state. If the electron is confirmed is coming to the ground energy level, then it will be n minus 1 by 2. You have to remember the language or catch the language of the question. If they are saying total number of spectral line, then n2 minus n1, n2 minus n1 plus 1 upon 2. Take the screenshot of these points. And if they are saying total number of spectral line, they are also saying the total number of spectral line to ground state. If they use the word ground state, then you have to use the formula n minus 1 upon 2. Okay. Similarly, the number of spectral line in specific region, they are asking only in Balmer region, only in Paschen region, like this, then only n2 minus n1. This way you can calculate the number of spectral line. In this video we discussed about what is a spectrum, the classification of a spectrum, and the simplest spectrum is the hydrogen have so many spectral line because the electrons are coming from the higher energy level, have so many possibilities to come to the lower energy level, even having the single electron. And also we discussed about Rydberg formula, how to calculate the maximum wavelength or the minimum frequency and so on. We discussed about the number or the type or the naming of the hydrogen spectrums line, like Lyman series, Balmer series, Paschen, Barakat and Pfund series. And then lastly we discussed only the mathematical approach of the spectrum. These formulas are very important. I request you all of the students to please write these formulas and solve the numericals related to this. I can promise you that no question will be can be out from these formulas. And I think if you use these formulas, this is the short tricks formulas, you can save your lot of time in the competitive examination if you are planning to give NEET and JEE or any other competitive examination. Because in competition almost all the student knows what is a spectrum, but the smart student is though who can solve the question in a shorter interval of time with 100% accuracy. Thank you for watching this video. We'll meet you in the next class.